tornadoes tearing up parts of the South. This follows an unusually turbulent January and February, and we wondered, should we start bracing ourselves now for more tornadoes each winter? We looked beyond the headlines for some answers.
Everybody was in our science building. We all got together. A man came into each room and said, "Everybody, if you have a Bible, open it."
I just heard that sound. I never heard a sound like that before. Never.
Never seen anything like this. This is devastation.
A devastating tornado in Memphis, February 5th, and an equally devastating beginning to 2008 in the South. The preliminary numbers tell the story. At least 225 tornadoes through March 3rd, about 3 times more than the 10-year average. That includes a record-smashing 138 in February, which is almost 5 times the 10-year average and destroys the old record by 55 tornadoes. 79 of those struck February 5th and 6th in an outbreak that in part almost destroyed Union University in Jackson, Tennessee, northeast of Memphis.
Guys were coming in to our dorms, and they were like screaming girls' names, and it was like complete silence at first, and then like people were everywhere, and it was insanity. And then we were trying to pull people out of their rooms that had no walls, that were stuck in their bathroom, that were like flooding, and it was chaos. It was complete chaos.
The tornadoes have left emotional wounds worse than any physical damage. There have been 67 deaths this year. And what's to blame? The deadly ingredients were unseasonably warm temperatures at the surface and cold air carried by powerful jet stream winds higher in the atmosphere.
It's a dangerous mixture of ingredients because the cold jet stream moving over top of warm waste air makes for intense instability, intense thunderstorms, and the changing wind directions between the southerly flow off the Gulf of Mexico and the west winds aloft allows those thunderstorms to turn, rotate. Those are the kind that our supercells produce tornadoes.
It's not unusual for the relatively warm South to have tornadoes in the winter months, but not the Mid-South, Illinois, Indiana, and Wisconsin, which have also had tornadoes. This year's onslaught in January and February was the second largest on record.
It'll be hard for a while, but we'll be okay.
To talk more about these tornadoes that we've been seeing, we're joined by our meteorologist, Mike Bettis. And Mike, this is a La Nina year, so that does mean warmer temperatures in the southeast.
You generally can draw that correlation. I mean, when you have this kind of pattern that sets up, it typically means anywhere from Kentucky, Tennessee, southbound, we typically have warmer temperatures. That really has played out this year, especially in February. So many places are seeing temperatures they'd normally see in, say, early May, especially if you look at a place like Memphis. When they had their tornado outbreak early February, temperatures almost 80 degrees, which is exactly what you would see typically 3 months later. So we're seeing kind of everything moved up at periods basically from winter to spring, which of course then means you have a chance for springtime thunderstorms.
Right, and there's a direct correlation between these warmer temperatures and these tornadoes.
Well, at this point it seems like there is, because you have to have at least that ingredient there. You have to have the warmer temperatures in place in order to help thunderstorms develop, in order to have tornadoes develop. And when you have these temperatures that are 20 to even 30 degrees above average, you've got that one key ingredient that's there. And the pattern then sets up also for the upper level atmosphere at the exact same rate to basically set up where it needs to for thunderstorms to develop across the South and even the Mid-South. And February, huge record-setting month for us for tornadoes.
Right, and what do these warmer temperatures say to perhaps the future as far as the tornado season goes?
We always like to prognosticate well into the future, but I think you could draw a lot of reasoning here. Tornado season is going to be probably lengthened now if we continue to see this warmer trend continue for us, or we may actually see tornadoes occur every single month of the year on a greater basis than we see now. So what we typically think of as tornado season in spring may now actually be year-round, which means we have to completely rethink how we educate ourselves and think about tornado safety. We have to think about it January through December now.
Right. Okay, Mike Bettis. Thank you, Mike.
Do it.
Well, for those outside of the weather business, one tornado may seem like any other tornado. You see one, you run for cover. But for meteorologists and emergency managers, there's good reason to be able to measure the strength of a tornado. It helps both for predicting the level of danger and for figuring out what happened in the aftermath. So tornadoes are measured on what's called the Fujita scale, and the creation of that scale made it to number 47 on our list of the 100 biggest weather moments.
Ted Fujita is probably the most important scientist in the history of the study of tornadoes.
Ted Fujita was my mentor. Probably his greatest contribution was that he could make things so visual. He had tremendous drawings, conceptual drawings that not only could be understood by the meteorologists, but also the public.
He has been quoted as bringing order out of chaos.
He developed the Fujita scale, the scale that's used to estimate tornado intensity. His scale goes from 0 to 5, with 0 being the weakest.
F0 is pretty much the smallest minimal tornado. F1 and F2, now you're starting to get into some substantial structural damage.
Well, I was in an F2 and got to see it firsthand. An F2 rolls vehicles. It can roll vehicles over. It shears telephone poles off. It's plenty powerful. It's a killer.
F3, there's nothing standing but an interior bathroom or closet. The roof's off, most of the walls are done.
F4, we're talking about the entire well-constructed house being leveled.
And Dr. Fujita liked to say that F5 in some ways is better. At least the tornado has swept the foundation clean. You can just start all over.
In February 2007, the Fujita scale was updated to become the Enhanced Fujita Scale, or EF scale.
And what we've realized now is that it doesn't take as much wind to destroy these structures, a la the Enhanced Fujita Scale. A rating that used to be F4 in some cases would now be an EF3, which is a wind that's not as strong, but yet cause the same kind of damage.
His scale was as good as anything we have, and it's likely to be all we have for a long time yet to come.
Dr. Ted Fujita died in 1998. He was also recognized as the discoverer of downbursts and microburst winds. He developed that theory by studying starburst patterns in forests and cornfields immediately after thunderstorms and tornadoes.